NERSC is the National Energy Research Scientific Computing Center. We are the Mission High Performance Computing Center for the Department of Energy Office of Science. As such, we support an incredibly broad range of science, from astrophysics, chemistry, biology, geoscience, really anything that the Department of Energy supports, and those users that need high-performance computing, they come to NERSC. Our latest supercomputer is Cori, is a Cray XE6 system with Intel processors. Applications are going to have to adapt. There's new technologies in Cori, there's new technologies in the Knights Landing processor, and these applications may not be prepared to take advantage of this architecture. So what we've decided to do is really focus on about 20 different applications, and these applications are in a program that we call NESAP, the NERSC Exascale Science Applications Program. These are teams that want to focus on their science, they want to focus on their applications, and right now we're at this turning point where if applications teams don't spend some time looking at application performance, they really could be left behind. And so the NESAP program is providing that focal point and allowing users kind of the time and the resources to be able to really focus on code modernization, preparing their codes for these next generation architectures. One of the reasons we're moving to the Cori architecture is due to energy efficiency. The Cori architecture with the Knights Landing processor is one of the steps that we need to take in order to move this very diverse workload at NERSC to more energy efficient architectures. Knights Landing processor will have more than 64 cores on a chip with up to 4 hardware threads each. So this is an incredible increase in the amount of parallelism our users are used to. And so what they need to do is make sure their applications really scale, whether that's using OpenMP, MPI, or newer programming models. And they'll need to make sure that threading capabilities are enabled in their applications. But now we're seeing vector units of 512 bits, and that's something users can no longer ignore. And so we're working with our users with Intel to get really good vectorization on the Knights Landing processor. One of the things I'm really excited about is the high bandwidth on-package memory on the Knights Landing processor. So one of the challenges for our applications will be how exactly they can take advantage of that high bandwidth memory. Are there certain arrays that they can put into the high bandwidth memory? Should they use it as cache? This high bandwidth memory is really an opportunity for our application teams to get much higher memory bandwidth, much higher application performance. Preparing these applications for new pre-exascale architectures requires a lot of different skill sets. You need people who understand the architecture, you need people that understand the application performance, but you can't do these in a vacuum. You have to have the science and the application teams really close by so that the improvements you're making in the code are scientifically viable. What we think the NESAP program really does is bring together those experts from Intel, from NERSC, and the application teams, and you see these people all working together closely, and then they come out after a deep dive session with code improvements of maybe 2 or 3 times. There are about 20 application teams that are part of the NESAP program, and I think one of the ones that's most exciting is to see the improvements in these climate models as part of the NESAP program. These climate models are incredibly important for understanding our environment and the warming that's happening on the Earth. And so what we want to do is make sure that as we move to more advanced architectures in the next 5 and 10 years, that these climate codes really can take advantage of all the features on these new architectures. We want to make sure we're making changes and encouraging changes that will last throughout the next 5, 10, or 15 years. One of the things I've always enjoyed about computer science and computing is that the computers, they don't know who I am. They don't know if I'm a man, I'm a woman, my race, my creed. They just know if I am computing right or wrong. We need everyone in high-performance computing and scientific computing that we can get, because we are not going to be able to solve the problems of this next century with only half of the workforce participating.